Welcome to our demo for PostCENN, where we integrated machine learning models, namely neural networks for cardinality estimation into Postgres. So cardinality estimation has a high impact on query processing. You can see here that with better estimates we get better query plans. And in our demo we want to give the user the possibility to test different estimators, especially the neural networks. So as an example for neural networks, we integrated our local model approach into Postgres. So the difference between any other approach and our local model approach is that they only focus on a small subpart of the schema, of the database schema, called the local model context. And only in this context, we are able to use our model. So a context can be anything from joint tables to a base table. And this focus on this small context gives us the possibility to compare machine learning approaches or neural networks and histograms better, because you will be able to compare in these contexts the query runtimes, the query plans, and the cardinality estimates. So let's have a look at our prototype. So here you can see the creation of the context. So as mentioned before, you have to decide where you want to use your model. So we already created context over the tables movie, info, and title from the IMDb dataset. If you want to create your own context, you can click here and then you can define your tables and columns you want to use. So every context needs a neural network. You can train different neural networks for every context. So here we trained 3 different models for our context test with the names 2, 3, and 4. And you can compare their setup times and their average Q error on the validation data. If you want to have more details, you can click here and you see the configuration of the training and different other metadata. With these 3 models, you can now test your estimators. So both the traditional and the neural networks can be compared in the benchmark tab. So first of all, you have 2 modes here. First one is a single query performance evaluation, and then you have the benchmark performance evaluation. So here I've run this query, and you can now compare the cardinality of both estimators, the Q error of both estimators, and the runtime of both estimators. So this is the actual cardinality, so the Q error is calculated from these 2 values and this value. And you can see in this case, the neural network estimator is better both in Q error and runtime. If you now want to have a look at more than one query, you can select a file where you prepared more than one query. So this file contains 4 queries in our case. And I've run this with the last trained model. And now you have a more statistical view on the data. So you can see the neural network estimator still produces better runtime on average, also better Q errors, and you can directly compare the Q error for each query in our benchmark in this plot down here. So this concludes our presentation of PostCENN. So you will be able to compare traditional estimators like histograms from Postgres with our neural network estimators, the local model estimators.